Welcome to this Algebra 2 session on applications of formulas and solving literal equations. So what are we going to be doing today? We're going to be finding the value of a variable in a formula, given the value of the other variables, solve a formula for specified variables, and use formulas to solve real-world problems. So what is a literal equation? A literal equation differs from other equations because you're not solving for a specific value, but for a specific variable. So solving a literal equation follows the same rules as solving a linear equation. So some common formulas that you're going to see are area equals length times width and other area formulas. Distance formula, distance is equal to rate multiplied by the time. Force is equal to mass times acceleration. Interest is equal to principal multiplied by the rate multiplied by the time. So these are just some common formulas. There are quite a few formulas, but you may see these more frequently than others. Remember, you can pause the video or recording if you need to write something down. The first problem that we're going to look at, this is not a literal equation. This is just a regular linear equation. But I wanted you to see the steps involved in solving this, as we've done problems like this in the past. But that will help us when we go to solve a literal equation. Oftentimes students forget, when they see all variables in a problem, they forget the steps that they know for solving linear equations. So let's look at this first one. If we look at 18 equals to 3x, the 3 is multiplying the x. So in order to solve for x, or isolate the x, I need to divide both sides by 3. And so I get a final answer of x equal to 6. Now, how does that help us with this problem? Use the formula below to answer the question. Interest is equal to principal multiplied by rate multiplied by time. What is equal to r? So what they're asking you to do here is to solve this literal equation for r. So what they want you to do is isolate r on one side of the equation. So since it's on the right side, I'm going to isolate it on the right side. So what we're going to be doing is isolating the variable on one side of the equation. So what you want to ask yourself is, when isolating r, or when looking at just the r, what are the other variables doing around r, the p and the t? What operation is being performed there? Well, if you look at it, the variables are written right next to each other, so that indicates to us multiplication. So the p is multiplying the r, and the t is multiplying the r. So if I want to isolate r on the right side by itself, that means I need to take the p and the t to the other side of the equation. And since they are multiplying r, I'm going to divide them to the other side. So if we write that out, divide both sides by pt, p times t, because they are multiplying each other, and I get r is equal to I divided by pt. So r is equal to I divided by pt. So again, identify the variable you're isolating, identify the operations that are being performed, and then do the opposite to take the variables to the other side of the equation. So again, because p and t were both multiplying r, I'm going to divide those sides by pt. And this is my final answer. Just like I did on this last problem, where the 3 was multiplying the x and I was isolating the x on the right side, so I divided both sides by 3. And that's exactly what we did here as well. So when you see a problem involving all variables or mostly variables, replace all the variables but one with numbers and see if you can identify the steps that you would have to do to solve the problem, because that can help. And then just do those same steps with just the variables. All right, next problem we have. What is the value of W for the formula area equal to length times width if A is equal to 136 centimeters squared and the length is equal to 34 centimeters? So our area formula is length times width. They give me the area, which is 136, so I'm replacing the A with 136. And they give me the length. The length is 34. I don't know the width. That's what I'm trying to find. So I'm going to solve this equation for W. So I look to see what operation is being performed on the right side. It is multiplication, so I need to divide to take the 34 to the other side of the equation. So dividing both sides by 34 gives me W equal to 136 divided by 34 is 4. And so my width is 4 centimeters. And last but not least, let's look at an interest problem. Suppose a bank is offering its customers 3% interest on a savings account. If a customer earns $225 in interest at the end of 5 years, how much did they originally deposit? So we are talking about interest, so we're going to use the interest equation, I equals P R T. And if you're not sure what these stand for, let's write them out here on the side. I is interest, P is principal, R is rate, and T is time in years. Rate is going to be a percent, so you're going to want to change that to a decimal when you actually go to use it for a calculation. So the rate is usually given as a percent, so you're going to want to change it to a decimal in order to use it in the calculation. So looking at this problem, the interest they're telling us is 225, so I'm going to replace the I with 225. The principal, do we know how much was originally invested? We don't, because the question is asking us how much did they originally deposit. So P is actually what we're trying to find. The rate is 3%. So 3% needs to be converted to a decimal by dividing by 100 or moving the decimal point 2 places to the left, which will give us 0.03. And I'm going to put that in parentheses. And the time is 5 years. So I'm going to work on solving for P here. My first step would be to multiply the 0.03 times 5, which gives me 0.15, or 1,500. And then I have the 0.15 multiplying P. So in order to solve for P, I'm going to divide both sides by 0.15. So dividing both sides by 0.15 will give me a principal amount of $1,500. So $1,500, if I want to write that out, so I'm writing in yellow here, so let me change my color. $1,500 was originally deposited. That ends the session on literal equations and applications.